Alright, hello everybody. My name is Sheep, and today I'm going to solve problem 189, rotate array from LeetCode. This is part of the top interview 150 study plan provided by LeetCode, and it's a medium problem, so let's get into it. Given an integer array nums, rotate the array to the right by k steps, where k is non-negative. Now, we can look at the example. The problem is pretty self-explanatory, but let's look at the example so we can get a better visualization of it. So 1, 2, 3, 4, 5, 6, 7, and we move 3 steps. So the output would be 5, 6, 7, 1, 2, 3, 4. As we can see, we have brought this sub-array over here, and we have moved it to the beginning of the array. Now, we can translate that directly into code, but there would be a problem. So if we translate that directly into code, we would have to add elements at the end here. For example, we pop back our last array, which is 7, from the vector. So the problem gives us a vector. We pop back 7 and we put it over here at the beginning of the array. What we're actually doing is moving all of these other elements back one element to give space to this element instead of just attaching it from this end, right? Instead of attaching it from this end, like how we would do when we attach elements from this end, we would have to move all of the other elements back one place. So that takes a lot of time. If we do that many times, it takes a lot of time. So that's not what we're about to do. What we're about to do, I propose, is that we're about to reverse this array once. We would reverse this array, so 7, 6, 5, 4, 3, 2, 1. And now if we go from here, go from 5, which is the third element, so our k is 3, we go from 5, because the number of steps is 3, right? So the first time we moved 7, the second time we moved 6, and the third time we moved 5. So now we go from 5, and we pop it back right here. That doesn't take us long, right? The same with 6 and 7. And how do we get rid of all of these, right? Because if we get rid of them, boom, then we have to move all of these elements back one place. It also very time consuming. So what we're doing is we reverse the array again. So 7, 6, 5, 1, 2, 3, 4, and then 5, 6, 7, right? And then we pop the last three, right? We pop the last three. So that is our final array. So now that would be a bit quicker as I've experimented. So now we can translate that to code. All right, so at first we can save time by calling n the num size, right? And then we can do this next step. This is very important because as we move it around, we move these elements to the right. At some point, it would return to its initial state, right? So it would return to its initial state if the number of steps is equal to the size of our vector or our array over here. So that's what we're gonna do. We're gonna simplify it, and we're gonna use k, mod it to the size of nums. All right, there we go. And now we would reverse our nums, begin and end. Right, so after we've reversed it, we would do what I have told you, what I've explained to you before. We would do that's not right. That's just mod k. We would push back the elements from 5. All right. So nums push back. All right. So after we've pushed back all the elements we've pushed back all the elements we need. We will now reverse it. Reverse the whole array again. Right, and now we would pop back the elements. So we just copy this whole thing over here, and then we pop back. But with the syntax for popback, we do not put anything in the parentheses, and that would be it. That would be a problem. Let's run it. There we go, and let's submit it. Yeah, that's very good. So, I think, yeah, that's right. So that's it. That's I think in my explanation I did something wrong, so I'm gonna amend it right here. In our explanation, 1, 2, 3, 4, 5, 6, 7. I said we reversed the array 5, 6, 7, 6, 5, 4, 3, 2, 1, and then we move from. I said we move from 5, but we don't actually move from 5. We have to move from 7 because now we've reversed it. That is where I got wrong, so I'm really sorry. So it will be 7, 6, 5, 4, 3, 2, 1, and then 7, 6, 5, right? And then we flip it. It would be 5, 6, 7, 1, 2, 3, 4, 5, 6, 7, and then we pop the last ones. So this would be our answer array. Yeah. So I'm sorry about that. I only realized after I coded it back. Yeah, but I amended the problem, and you guys please note this and this algorithm. It works well. So that's it works well. So that's the video. That's the problem. If there's any question, please contact me, comment, and I'll get back to you as soon as possible. I'll see you guys in the next video.